All right, hello everyone, this is Mr. Crozier and I'm here to help you with the first part of our worksheet, Unit Circle, Part 3, Side 3. All right, in this first section, in every single problem, we are given angles and we are asked to find the ratio that goes with it. And when we're talking sine functions, we have two ways we can do this. We can start with an angle, use the sine function, get a ratio out here. Or if we start with a ratio, we can use the inverse sign, go back to an angle. But our first section is just this forward operation, going from angles to ratios. So let's focus on that. And again, our ratios are on the back of this. Sine is opposite over hypotenuse, cosine is adjacent, tangents opposite over adjacent. So make sure you have this reference sheet to help you out as you go. So the first problem is sine of 5 pi over 3. Well, how do we do that without a calculator? Well, everything you need to know is in the unit circle. Hopefully by now you have a pretty good understanding of that. Let's see what we have here. We have 5 pi over 3. So these are thirds, 5 thirds. 1/3, 2/3, 3/3, 4/3, 5/3 is this angle down here. Here's the angle theta that we're talking about. It starts here at 0, goes all the way around to here. So what is the ratio? Well, if I draw a right triangle, the ratio is the opposite side, which is this one, and hopefully we know that this is √3 over 2 negative, and this is 1/2, and this is 1, and that's the thought process you have to go on your unit circle. We know all the sides. It's either 1 over 2, √3 over 2, or if it's in the middle, it's √2 over 2, but this is our triangle. The sine is the opposite side over the hypotenuse, and this is why we're using the unit circle, because it's over 1. So the ratio is just √3 over 2. All right, on to the next problem, cosine of pi over 6. Well, where's that angle? Well, that angle is right here, and it forms that triangle. Cosine is the adjacent side, so it's this long side. It's not the middle. The middles are √2 over 2, if you remember, but it's not the middle, it's the long side, and the long side is √3 over 2. Tangents. Well, where's tangent of 240? Well, 240 degrees, that's going to put us down here, and it's going to draw this triangle, and the tangent of 240, I'm going to write it out over here, would be the opposite side, which is the long side, which would be the negative √3 over 2 over the short side, and that would be a negative 1/2. And the quick version of this is negative makes it positive. These cancel out, and you have just √3 over 1. There's only a couple options for tangent, and you'll get really fast at it. Cosine of 150, well, there's a 150-degree angle. There's a triangle. Cosine is the adjacent. So what's adjacent? Well, that's this distance here, and that's the long 30, 60, 90 triangle. So that's negative √3 over 2. Cosine of pi over 2. Well, where's pi over 2? Well, pi over 2 is this angle here, and that doesn't make a triangle. So our thinking with the triangle kind of falls apart there, but we do know that it is a 0.01. And we do know that this is a cosine value and this is always the sine value. So the cosine of pi over 2 is simply 0. Tangent of pi over 3, well, that's this big triangle here. And we have the same thing we had down here. We have the long side, which is √3 over 2, over the short side, which is 1/2, simplifies down to √3. They're both positive. Kind of running out of room here, so I'm going to get a different color. Cosine of negative 45, well, that's this angle here, negative 45 degrees. And what is the cosine? Well, the cosine would be this distance, and that's the middle distance, so it's a positive √2 over 2. Sine of 135, well, that's out here. And sine is the opposite side, and this is again in the middle, so it's this set of points here. And we're going to have √2 over 2. All right, everything on this is about using the unit circle, finding the sides. Sine is about the opposite. Cosine is about the adjacent. Tangent is when you divide them. Just keep in mind all the different fractions you could have.